I'd like to show you how to design a microstrip patch antenna in this video, but before going to software environment, I will review briefly the theoretical background of the antenna. In the screen, the figure is showing the microstrip antenna with dimensional variables indicated by various alphabets. The orange region is a copper patch and the greenish region is FR4 substrate having dielectric constant 4.3 and thickness 4.5 mm. These two equations are used to determine the length and width of the patch and a neglected fringing effect to avoid complications. I would design an antenna that will operate in GSM 1800 band, and that means the center resonance frequency should be 1.8 GHz. Now replacing FR equal to 1.8 GHz, epsilon R equal to 4.3, and C, which is the free space speed of light, we found the length approximately 38 mm and the width 51 mm. Now we would switch to software environment to initialize design process, but do not forget this figure because it will be necessary during design process, especially in the calculation of coordinate value of the points. Let's now launch CST Studio Suite 2010. Select CST Microwave Studio, then press OK. Since microstrip patch antenna is a planar antenna, select Antenna Planar. Let's resize the working plane. Go to Edit menu and then select Working Plane Properties. Give a size 100 and change the width to 10 and snap width to 2.01. Before starting the design, it is a good practice to define the parameters of the antenna. At this moment, we need the diagram of the antenna. Here it is. Let's now specify the required parameters according to that diagram. The first parameter is L. For the length of the patch, its value is 38 mm. Then W for the width of the patch, it is 51 mm. Then LF. It is the length of the microstrip transmission line. This is the thin copper microstrip transmission line which has length LF and the width WF. So give a value LF equal to 31.5 and WF equal to 8.7 mm. Next parameter is Fi, which is this distance, and give it a value of 12.5 mm. Next is GPF. It is the gap between the patch and microstrip feed line, and the value of it is 1 mm. Then specify the thickness of the substrate, which is indicated by H, 4.5 mm. The last parameter is MT, which is the thickness of copper layer on FR4 PCB board. Give it a value of 0.1 mm. We have just completed parameterization of our antenna. Now we would begin the construction of the geometric structure of the antenna. So turn on the local coordinate system from WCS menu. I would construct the FR4 substrate at first, so select brick and press escape key. Give this structure a name, substrate. Now go back to the diagram of the antenna. The substrate width is twice the patch width. Also the substrate length is twice the length of the patch. If the width is considered along U-axis, the half of the width is along negative U-axis and the other half is along positive U-axis. Same technique is applied for the length. Now specify the height along positive W-axis and select the material as FR4 from material library. Here is the FR4. Press OK to complete the substrate. Now the ground plane is to be created. Select this icon from the toolbar and rotate the substrate. This is the rear face of the substrate. Now go to Object menu, then select Peak and pick face. Double click on this face and select WCS, then select align WCS with selected face. Now again select this face and then select extrude function from the toolbar and give it a name, ground plane. The height is the thickness of the ground plane, which is MT. Select copper from material library. Here is copper. Press OK. That's our ground plane. Now come back to the front face of the substrate to design the patch. Select this face and align the local coordinate system with this face. Now select break and press escape key. Give it a name, patch, and specify the coordinates as shown. Width is along U-axis and the length is along V-axis. Specify the height along positive W-axis and select copper from material library. That is our patch. Now we need to design microstrip transmission line. This part is going to be more difficult as compared to the previous part, so I need your full attention. It needs solid mastery over the coordinate system to design dimensionally accurate structure in CST Microwave Studio. This part involves intense use of coordinate points found by calculations. I have tried to simplify it by visualizing with the help of figures. Anyway, let's begin the design of the microstrip transmission line. At first, I'd create a rectangular empty space on the patch, so select break and press escape key. Give it a name, empty space. Now let's see a figure. This pink region is the intended empty space to be created on the patch. We need coordinates of the two corner points of the empty space as shown in this figure. U minimum, V minimum and U maximum, V maximum are the 2 points we need. I have already calculated the corresponding coordinate values of these points. This calculation must be done manually. This is the most complicated part in structural design. However, it becomes easy with a lot of practices. Anyway, specify the coordinates as shown in this figure. Now the thickness must be specified along the W-axis and select nickel from material library. This new window has appeared because two objects have intersected one another. This function is known as Boolean combination. Select the last option to remove this rectangular space. The empty space will be created now. Here is our empty space. Now let's design the microstrip line. Select break, press escape key, give it a name, microstrip. Now let's look at one of the figures. The pink region is the microstrip line to be created. We need 2 corner points of the microstrip line as indicated in this figure. Again, I had to calculate the coordinates manually. So we specify the coordinates as shown in this figure and select thickness along positive W-axis and select copper from material library. Here is our microstrip line. But one more thing is remaining to complete the design process. Come to this folder named component 1 that is located here. There are 2 separate objects called patch and microstrip, but we need to unify them into one object. So click on patch, go to objects menu, then boolean and add, then click on microstrip and press enter from keyboard. That's it. They have been unified into one object called patch. And we have applied Boolean add function to unify them. The design process is complete now. This is the microstrip patch antenna which would operate in GSM 1800 band, and the antenna is fed by this microstrip transmission line. That's all. Hope you enjoyed. Thank you very much.